All right, I have to give a shout out to Eli St. Clair, my son, video man, for helping me get these videos in Western Canada. Turn it over to you, Eli.
Let's go. Okay, so we're in bog systems. Bogs, maybe you're more familiar with swamps. Swamps tend to be more nutrient rich. Bogs are very nutrient poor. Bogs are defined by having peat moss. There it is right there, peat moss. That builds and layers on itself. And over time, this can become 10, 20 feet deep. It's also defined by having a really high water table, which means that liquid water is maybe 2 feet down below the surface of the current level of peat moss. And this peat moss produces tannic acid, so the water in the water table is very, very acidic. Which means that the trees that grow in this area are stunted. Another reason it's so nutrient poor is because the tannic acid makes it really hard for bacteria and fungi to decompose any of the organic matter. And so nitrogen can't be recycled in the system, and it's very, very nutrient poor. So it's in bog systems like this where we get carnivorous plants that evolve. They modify their leaves into traps to capture insects to get their nitrogen needs met. So something like Venus flytrap evolved in a bog system where it's just almost no nitrogen available because it's all nutrient cycling is so slow because of the high water table and the very acidic water. And that's where we see these plants evolve. Notice these trees right here. So there's a forest growing on the bog. But these trees, which may only be 10 feet tall, for example, may be hundreds of years old. They grow very, very slowly, and that seems like a contradiction because there's water down there, but roots can't grow in water. Any living plant tissue is doing cellular respiration requires oxygen. So if you put your living roots into a water table, then they'll die from asphyxiation from lack of oxygen. So where they have to grow their roots right at the surface above the water table. And again, there's not very much nitrogen because the high acidic water table makes it really hard for the microbes to cycle nitrogen. And so during the summer, winter is very wet, but during the summer it dries out and gets pretty windy out here and dries out all the surface soil and the peat moss where the roots are growing. So it's a water limited system and it's a nutrient limited system. So you look at some of these trees, all stunted. And if we go just over there, just away out of the bog system, you'll see trees that are the same age that are 200 feet tall. So it's really interesting here. It's a very biodiverse system. You can go into a place like just right in here and you can count probably 20, 30 species of different plants living in this area. So bogs are really interesting. Another reason that bogs are so important is because they only cover about 3% of the Earth's terrestrial land surface, mostly up in the northern latitudes, Siberia, Canada, but those are big, big continents that cover large areas. But they store about 25% of the world's soil carbon, right? So again, as these peat moss layers build upon each other, they can become 20 feet deep. So covers 3% of the Earth's surface, but with all that depth and all that storing of peat moss, and because it doesn't decompose very quickly, it stores a lot of carbon. So it sucks carbon dioxide out of the air through photosynthesis, stores it, acidifies it, and makes it really hard for microbes to break it down and re-release the carbon dioxide. I do want you to think about ways in which climate change could change the storage of carbon in peat bogs. What's something that could change that could release a lot of that soil carbon and transform it back into carbon dioxide under climate change and climate warming?